down, up, down, up, down, up, down, up. EA extensions. Hey, what's up YouTube? It's been a crazy busy couple of weeks. I haven't had much time to do much filming, but today I wanted to share with you something really cool that I'm working on for the next big build. That is a Warhammer 40k Space Marine, specifically a Grey Knight Terminator build, completely 3D printed, mechanical. It's going to be a full scale. It's probably, I thought T60 was insane. This is insaner, if that can be a word. So, what I've been working on in the last couple of weeks, quietly, is working on the internal frame. So, you gotta understand, I'm gonna be only up on relatively small stilts. I don't wanna be too high up because you get all kinds of stability issues and, well, this thing's 10 feet tall. So instead, what I'm gonna be doing is I'm gonna be extending the armor above me. So my head will only come up to the abdominals of it, and then the rest of it's gonna have to be all extensions. So I'm rigging up some crazy arm extensions in the internal frame. To do that, I started prototyping. What I started with was good old cardboard, my roots, and just trying to figure out leverage and mechanisms and all these things. I'm not sure if you can see it. Yeah. You know, just cardboard and some nails, not really health and safety, but yeah. So from here, I was able to figure out a basic idea of how I wanted the shoulder joints, the arms to move this way, then the elbows, and then of course ultimately the fingers. I didn't prototype the fingers in cardboard, but the idea is it's going to be all PVC frame and 3D printed joints using these clever, you know, you might know these from fidget spinner fame or skateboards if you're into that, 608 bearings to create a frictionless, well, there's no such thing as frictionless, a low friction joint that basically reduces the amount of resistance. So if I'm pushing something, it'll take a lot less effort to move my arms forward or move them up or whatever, which when you're talking something that could probably weigh upwards of 70 pounds, makes a difference. It really does. So cardboard, highly recommend. Don't discount it. And that turned into these. So what you'll see here is it's a 3D printed joint. This is actually the Mark 1 version. I've kind of refined it since this was friction fit, and friction fit, if you can get perfect, awesome. If it's not perfect, it either doesn't fit or it's too loose, which neither of those are particularly kosher. So, but you can see it just moves around pretty easily, and this is a linear joint, so this will only be able to go like if this is my arm, or if this is like my arm here, pretty cool, right? But you know, the neat part is when you get these linkages and joints together and working together, you can get some pretty neat sort of mechanisms and ways to kind of almost remotely control via mechanics, no electronics needed, an arm or a hand, or eventually I'm hoping to probably make an extension so I can control the fake head at the top. So this is going to be amazing and absolutely crazy at the same time. And all right, so this is going to be shoulder, this part right here. See, this entire section. So shoulder, my arm is going to be mounted here, and it's going to go up and down like that. So the actual fake arm, the extension, is going to be resting here, and whatever I do down here is mirrored. So up, down, and then there's another joint. This is the back where it's going to swivel. Pretty cool stuff, eh? Bit of a work in progress. Some of the joints are, as you can see here, not cooperating. So a quick word on how I made all the frame joints. These were all 3D printed using the monoprice Delta, which of all my printers I've had so far, for this particular use case, was an amazing MVP for two reasons. One, it was extremely quick. I could pump out parts about this size in about 15 to 20 minutes a piece, which means if I needed something that I wasn't sure, I was kind of working and designing on the fly, I could sketch up a design and boom, pop, 15 minutes later I have a part. No waiting an hour or 3 hours for the part to print it, as I did with some of my Cartesian printers. Second thing, and this is the part that really surprised and impressed me, is the tolerances have been absolutely amazing. I don't know what it was, if it's deltas or how well tuned it is out of the box, but I'm able to take my bearings, slap them in, boom, boom, done, fits every time. With the Cartesian printers, my initial tests, sometimes it was too big, sometimes it was too small, and it was really irritating because I had to throw out and waste a lot of parts or do modifications like drilling them out so things would fit and stay together. Not so with the Delta. So I gotta say, I'm really impressed with the performance of the Monoprice Delta for really rapidly prototyping small pieces for the my builds. Now, I know a fair amount of you have been asking me, where can I get my hands on a Monoprice Delta? As for the longest time, the only way you could get them was the Indiegogo, which was held over last summer. Well, I'm pleased to say, as I just found out, that the Monoprice Deltas are now available on the Monoprice website for an astoundingly cheap $159. It just blows my mind how cheap 3D printers have gotten since my first printer, which cost me like $700, which is just, yeah. Anyways, super easy to use, has auto leveling, a all metal hot end, limited Wi-Fi connectivity if you do some modifying and tweaking, though I personally prefer using a Raspberry Pi and AstroPrint for all my wireless and remote printing needs. All in all, pretty solid printer if you want something that's easy to start out with and you don't mind the tiny bed size. So yeah. Thanks so much for watching. If you enjoyed this video, don't hesitate to hit that like, share, and subscribe button. Thanks again. See you in the next video.